This is the video for questions 26 through 30 of the final exam review for Math 1050. Question number 26 gives a cost function and asks what is the minimum cost. So whether you're finding minimum or maximum in a quadratic function, this is quadratic because the highest power is 2 on x. Regardless of what you're finding, you would use the formula x equals negative b over 2a. So the a and b are just like you would find a, b, and c for a quadratic formula. So a in this case is 0.8, b is negative 496. So you could plug those in, negative 496 over 2 times 0.8 equals, and you could put that into your calculator. Oh, I'm sorry. Yeah, no, that's right. And you'll get 310. Now, this is not the answer. This gives you the x value of the point where there's a minimum. So this is basically a parabola, and it's facing upward like this. So it's going to have a minimum point. And what you just found was the x value of that minimum point. But they're asking for the actual cost as opposed to x, which is the number of items that would make it that cost. So what they're wanting is the y. So to find the y, you have to put 310 back into the cost equation. So you're going to evaluate 310, 0.8 times 310 squared minus 496 times 310 plus 86,192. So the answer that you'll get is hopefully $9,312. That's the minimum cost. So this would be the y value of that minimum point. Number 27 gives you a picture of a graph, and it asks you a couple of questions about it. So the first thing it asks is, where is f increasing? So it's increasing here up to this point, right? So remember, increasing, decreasing, I'm gonna like give them the answer from left to right. Everything is left to right except for range, which is up and down. So it's increasing from, this goes on to negative infinity. When does it stop increasing? Right here at -2. So, and remember with increasing, decreasing, I always use parentheses. So negative infinity to -2. It also increases starting here, which I didn't really write that very well, right there, which is 3, and it finishes increasing right here, which is 7. So, I'm sorry, we don't put union for increase and decreasing. In these two locations, so 3 to 7, it is increasing. Okay, the next question. The function f has local maxima at which x values? So these are our two maxima, our local maxima, here and here, and they want the x values for those two positions. So this is a -2, and this is a 7. -2, 7. The third question says, what is the sign of the leading coefficient of f? So f is this function, and because the tails are going in the same direction, it's going to be an even degreed function, and because they're both going down, then that leading coefficient will be negative. So the sign of the leading coefficient is negative. Had these two tails been going up, then it would have been positive. And then the last question says, which is a possibility for the degree of f? Well, because the tails are going in the same direction, it has to be even. So it's not going to be 5, 7, or 9. And then you count the local extrema. So I have 1, 2, 3. I have 2 maximums and 1 minimum extrema. So you always have to have at least one more for the degree of the function. So it could be 4, because that's one more than 3. But it also could be 6, or it also could be 8. So those are all the answers for that. Let's see what question 28 says, 28 says, use the factor theorem to determine whether x plus 1, let me put these away, is a factor of this polynomial. What? Okay, so is x plus 1 a factor of that polynomial? That's the question. And the factor theorem basically says, so they're asking if this factor is a factor of that. So there's a difference between calling something a factor and calling it a zero. If this is my factor, then my zero is -1. And what the factor theorem says is I can evaluate that -1 in the function. So I would have -1 to the 4th plus -1 to the 3rd minus 4 times -1 squared plus 4. This is a plus. So when I evaluate that, I get 1 minus 1 minus 4 plus 4, which equals 0. So if you get 0, it means you don't have a remainder. So therefore, this is a factor of that because it goes in evenly. So the answer to this is yes. Number 29 says for the polynomial 2 is a 0. So they give us that as a hint. They give us this polynomial and they say express h of x as a product of linear factors. So I think this is a pretty difficult problem. I already know that one factor, because 2 is a 0, remember the 0, like this -1 was a 0 here, the factor was x plus 1. So if 2 is a 0, then one of my factors is going to be x minus 2. So I already have that one. And in order to get the rest of them, then I need to divide out the x minus 2 from the original function and see what I have left. Okay, so x goes into x to the 3, x squared times x is x to the 3rd, x squared times -2 is -2x squared. Subtract that, I get 4 plus 2 is 6x squared. Bring down the minus 8x minus 8. X times 6x will give me 6x squared. 6x times x is 6x squared. 6x times -2 is minus 12x. Subtract that, and I get -8 plus 12 is 4x. Bring down the minus 8. X times 4 gives me 4x, and then this works out perfectly because they did tell me that that was already a factor of that. So this is what I have left, x squared plus 6x plus 4. But I can't just write that in there because it can also be factored into two smaller pieces. So how would I factor x squared plus 6x plus 4? It actually doesn't factor nicely, of course. So we're going to use a quadratic formula. A is 1, b is 6, c is 4. So I get -b plus or minus the square root of b squared minus 4 times a times c all over 2a. So I get -6 plus or minus 36 minus 16 is the square root of 20 all over 2. 20 breaks into 4 times 5, so the square root of 4 will come out as a 2, leaving a 5 inside, all over 2. I can reduce these, so I get -3 plus or minus the square root of 5. Now, the question is, how do we write that? So, you know, if my answer had been something easy like 2, then I would have written a factor of x minus 2. But it's not. It's this. So I'm still going to follow the same format. So I'm going to go x minus this, -3, and I'll do the plus 1 first, square root of 5, parentheses, and then x minus -3 minus square root of 5. And that is how you can type your answer in. and it's now factored all the way down to linear factors. How do I know they're linear? Because my x's are all raised to the power of 1. That's what makes it linear. This was quadratic because it still had a power of 2, so I wasn't finished with the problem. Okay, let's look at question 30, which I think I wrote right here. Okay, it says find a polynomial f of x of degree 4 with real coefficients and the following zeros. Now, this is a pretty lengthy question, so I'm gonna erase my whiteboard and use it so I have a lot of room. So, find a polynomial f of x of degree 4 with real coefficients and the following zeros. So, they tell me that -4 is a 0, which means I'm going to have an x plus 4. But they also tell me that it has a multiplicity of 2, so that means it's raised to the power of 2. Now, anytime I have an imaginary number, I'm automatically going to have its conjugate. So if this is a 0, then the factor is x minus I, and this one would be x plus I, or x minus negative I, which gives me the x plus I. So these are my linear factors, and what they want me to do is multiply these all out so that I get a polynomial of degree 4. So for starters, I'm going to do the x plus 4 times itself. So I'll need to FOIL that. So I get x squared plus 4x plus 4x plus 16. Now that whole thing is eventually going to be multiplied by these guys, which I will also FOIL. So I get x squared plus ix minus ix minus I squared. All right, let's do some simplifying. So x squared plus 8x plus 16 times x squared. These two cancel. I squared is -1. I have a -1, so that'd be plus 1. And now I have to multiply these out. Now you can do this in a couple different ways. I'm going to show you a way to do it using like a table. So alternatively, you would just take every member of this parentheses and multiply it by every member of that one. So you go x squared times x squared times 1. 8x times x squared, 8x times 1. 16 times x squared, 16 times 1. Collect all of your like terms, and you're done. But there's kind of a neat way of doing it using a grid, which I like. So I'm going to put x squared, 8x, 16 from this trinomial. Then here's an x squared and a positive 1. I'm going to make myself a grid. And each box will be the product of what's above and what's to the side. X squared times x squared is x to the 4th. X squared times 8x is 8x third. 16 times x squared is 16x squared. X squared times 1 is x squared. 8x times 1 is 8x. 16 times 1 is 16. And what's nice about this is it just organizes it really well. So I have an x to the 4th. I have an 8x to the 3rd. I have 2 x squares, so if I put them together I get 17x squared plus 8x plus 16, and that is my polynomial of degree 4, because the highest degree there is 4. So I hope that was helpful, but remember you can always just do your own distributing to figure that out. And I'll talk to you next video.